we're going to graph an ellipse with all the details. So, we're going to start by factoring out this 12. Don't like that. So 12 times the parentheses x squared. The 12 comes out of here too, and I'm left with negative x. Half of 1 squared, I'm going to say plus 1/4. That's my perfect number. And I just multiplied 12 times 1/4, so I'm going to add 3 over here as well. I'm going to factor out the 20. This 20 in front of the y squared. And the 20 comes out of the 40 as well, so I have 2y. So that means that completing the square gives me 1, but I really didn't just add 1, I just added 20. And let me move the 37 over there anyway. And let's see, 37 plus 3 is 40, plus 20 is 60. Okay, I can write this better. I can say 12 times x minus 1/2 squared plus 20 times y plus 1 squared, and then I'm going to equal 60. I don't want to equal 60. So maybe there we go. I'm going to divide everything by 60. Not quite as nice as what I'm used to getting here. I'm now going to have x minus 1/2 on top squared over 5. So a, well, let's see, I don't know what a is. Hang on just a second. I'm going to get 3 on them. Yeah, so I can talk about a in the first position there. 3 shows up down here, so I know that's b because it's smaller than 5. So I can say that a is the square root of 5 and b is the square root of 3. And the square root of 5, I think it's what, 2.2 roughly. 2.2, and the square root of 3 is 1.7 roughly. We'll say that h is equal to 1/2 and k is equal to -1. While I'm at it, c squared is equal to a squared. This is plus, so I'm going to say minus b squared. And so let's see, that equals 5 minus 3 equals 2. So c is equal to the square root of 2, which is about 1.4. All right, so not a big thing here. We have a center where? A center at 1/2 and -1, so let's see, about like that. And away from that in the horizontal direction, because this is horizontal, because a is underneath x, is 2.2 away from that. So, you know, roughly speaking, 3. If we said this was, wait, we said that was 1/2. Hang on, it's going to have to be further than that. I was thinking that was 1. If that's 1/2, then we'll say that's, yeah, it's not quite that much, is it? Sorry. It's 2.2, so it's not 2.5. So we'll say about like that. And same thing in this direction. We'll say 1 and 2. Something like that. Ooh, that doesn't look very level. But so we have that, and we also have in the b direction, how far are we going? We're going 1.7 in the b direction. So if this is, I said it was 1. Yes, I did. I said it was 1. Then we're going a little bit more than that. I'm going to have to move my label there. And a little bit more than that. I'm not sure I really believe it's that little. I think it needs to be more. Not too convincing. Alright, so there we go. And we can draw our beautiful ellipse here. Oh, that does not look good. And let's see, our foci are 1 point, not 1.5, so right about there and right about there. Okay, anything else? What do they want to know? Oh, I guess I should identify things. Yeah, I better identify. Oh, the eccentricity too. The eccentricity is E equals C over A, I think. And so let's see, that's the square root of 2 over the square root of 5. And so I'm going to have the square root of 10 over 5. That's eccentricity. It's a measure of how close to a circle, I suppose, we are. And we should label things. We should say the center is at 1/2 minus 1. The vertices are, I might just break down and use, I wish I'd have done this while I was doing it. Let's see. We'll say 2.7. We're still at -1. And also, we will subtract from 0.5, 2.2, and we'll get -1.7. Does that make any sense? I think so. -1. And yeah, our foci are from 0.5. Let's see, we're going to add, I forget, there we go, 1.9, -1, and we're subtracting, so we're going to get -0.9, -1. Okay? Right. And anything else? And we sketched it. We kind of sketched it. Okay. That's our ellipse.